Hey, good morning, guys. Happy Tuesday. Happy birthday. We should write that. Happy birthday to Sheridan. Hey, all right. Hope you're having a good lockdown party today. So we're gonna today get started on confidence intervals. Sorry guys, I've been abbreviating CI. I hope you guys know what that means. Confidence interval, and I use HT for hypothesis tests. So just a reminder, these are the questions that I want you guys to complete, these three, and then your quiz will be on Friday, same thing on AP Classroom. I hope that yesterday's quiz went by smoothly. I know it's a learning experience, and we're all learning right now as well. So our goals today, our goals of chapter 24 is confidence intervals, hypothesis tests, and then we're talking about pooling, which we'll touch on a little bit today. But today, let's just focus on confidence intervals. So I want to look at one question from your textbook. This is page, I don't know, it's number 25, page 571, number 25, okay? Go ahead and pause the video and write down your given information here. The things that you should be able to pull out, well, there's a table already, so we can just use that information. But go ahead and pause it and read what it's talking about. Okay, so first I think we should stop and reflect for a moment that there are these people who swam across a lake. Now this lake ain't no little lake, okay? So if you look at the female group, their average time was 1271 minutes, 1,271 minutes. That's about 21 hours. Okay, 21 hours is almost a day. So there are people that swam across a lake for almost a full day nonstop. And there's someone who actually did a round trip. Oh my gosh. Wow. Okay. So we're trying to compare if there's a difference between males and females. The times are given for both. Also, note that there are more females in this group than males. There's 22 females and 20 males, okay? And they start off by giving you those graphs right here. So you have two histograms and you have two box plots right here. These are going to be used for part B over here. So for part A, we don't quite need them, okay? But it's good to see that, look, this is more of a normal curve. Now the male one, it's not, right? This is definitely skewed. Is that skewed left or skewed right, class? If you said skewed left, you are incorrect. It's skewed right because the tail goes to the right, okay? All right, so let's write down our given information here. I know it's in a table for you, but I like to rewrite it so I can see it a little bit better. So the mean time for the females was 1271.59 minutes. The standard error for the females was 261.111. And then the number of people in our sample for females was 22. And then for the males, the average time was 1196.75. Standard error for the males was 304.369. And the number of males in our sample is 20. Okay, so this is what we're going to use right here. Oh, and we should also include in part A, it asks for us for a confidence level of 0.95. So there's two ways to do this. We can do this by hand, and as a good way to see it by hand, you should take a look at page 551, and we could also do it by our calculator. which is on page 553. All right. So I'm going to start by calculator first. Okay. So on page 553, have your calculator ready as well. It goes over the details, but we're going to go to stat, test, and then go ahead and look through your list. Go to stat, test, and then can you figure out which one we're supposed to use this time? We have two samples. We have two sample means. Okay, so don't pick two sample proportions, right? We're looking for two sample means. Now, you're probably guessing number 4. But if you guess number 4, look, we're looking for an interval this time, a confidence interval, okay? And number 4 is actually a test. So if you scroll all the way down to option 0, that's a two sample. So option 0 is two sample t int. And you guys remember for means, we always use t. Okay, for proportions, we use z. All right. So go ahead and go there, hit enter. I already put in my data. So go ahead and enter your data, or your statistics. You can pause the screen right there and type those things in. I'm gonna scroll down. Okay. Now we get to this question about pooled. For pooled right here, if you take a look at page 559, it gives you a little bit more information on that. But for now, just choose no. And quite honestly, you're most likely going to use no, okay? So hit calculate. Okay. When you calculate, you should get an interval of negative 103.2, comma 252.89, okay? Or you can rewrite that as 78.84. So this is the mean difference, plus or minus our confidence interval, and our margin of error is 178.05. Okay, so this is done by calculator, and let's write out the interpretation for this. So we are 95% confident that the difference in true means of the time it takes females to swim across Lake Ontario compared to males is between negative 103.2, oops, we don't need that, and 252.89 minutes. Okay, so good job. So that's by calculator. So let's ask that question about, they don't ask it in this question, but like, is there evidence, like according to your confidence interval, is there evidence that like there is a difference? Is there evidence of like males are faster than females or females are faster than males? So let's examine our interval a little bit more. So I'm just gonna write this number down right here. So our confidence interval, okay, goes from here to here. Now, we could have a difference. Remember, this 0, this represents the average time for females minus the average time of males, okay? So you could have positive difference, or you could have a negative difference. So let's go over what these actually mean, right? So if you have anything over here, what that means is that females took longer than males. Is that correct? Right? If you subtract female minus male, if it's positive, that means it took the females more time. Now, if you have anything on this side, what that means is that the males took longer than females. Now, what about the 0? That would mean that the male time is equal to the female time. There is no difference. So this difference that females took longer, this difference that males took longer. Okay. So if you look at our interval is actually, it goes from negative 103.2 to positive 252.89. Okay, so it actually straddles the 0. So we could say, you know, there is not evidence because it straddles a 0. The 0 right here means that they're equal to, okay? So make sure that, and I loved seeing this on that last quiz. You guys drew this out to see what it actually means, and I really, really appreciate that, guys. All right, so let's try this by hand now. Take a deep breath, because this is gonna be pretty fun. So, by hand, this time. Remember our, if you look at our formula sheet, it's our test statistic. This is the base formula for confidence intervals, plus or minus our critical value times the standard error. Okay, so it's always been the same for all the different tests. So this time our test statistic is we're using the average time for females minus the average time of males, plus or minus. Now, critical value, are we using a T or a Z here? Okay, those of you that said T, you're correct. T with the degrees of freedom, okay, times our standard error. So this formula now is going to be for 2 sample means. It's going to be the standard error of your females squared over the sample size of females plus the standard error of males squared over the sample size of your males. Okay. So you're probably wondering, how come it's subtraction but we're still adding here? Okay. Guys, take a look at page 3, page 374, chapter 16, okay? I'm gonna just turn there in my textbook. Okay, remember when we talk about adding or subtracting variances, that we always are gonna add the variances. Okay, so review that page, chapter 16. So this value is easy, right? This would just simply be these 2 values subtracted. The average time for females, average times of males. So if you subtract those, you'll get 78.84 plus or minus our critical value of our degrees of freedom. So remember in the past, degrees of freedom was simply our n minus 1, but this time we have 2 n's, right? Now, it's going to be very tempting for you to add the sample size for the females with the sample size of the males. Do 22 plus 20 and make that 42, and then 42 minus 1, make that 41. It doesn't work that way. There's a crazy formula, and I dare you. I quadruple dog dare you to do this. It's on page, sorry, I'm getting there. For this, I want you to see the bottom of page 549. Okay, there's a formula there, and read the footnote too. You don't have to do this by hand, okay? I would just use your calculator. So what I say overall for confidence intervals, do it using your calculator. Okay. Now, when you did this by calculator, if you turn it on, you'll see your degrees of freedom. Actually, the value comes out to 37.6718. Okay? Times, and then this is where you would write everything in. So the standard error for the females was 261.111 squared over 22 plus 304.369 over 20. Okay. And then for this right here, you could also use your calculator. Remember, you could do inverse t of 0.025 comma 37.6718. Okay. If you work all of that out, that's where you're going to get your margin of error, right? So this part is your margin of error, and this is your interval. So what I suggest to you guys, the parts that you may need to know for the AP exam is knowing this formula. But this formula is written on your formula sheet, right? So let's pull out our formula sheet and just mark down where that's at. We are now right here. So chapter 24, and our formula is listed right here. Now, this part, if you watched our updates on the AP exam, this part we're not covering this year. We're skipping this part. Okay? So you can go ahead and cross it out. But everything else on this sheet, you should know up to this part right here. And I'm just going to go ahead and cross this out for you. Okay? All right. So what I say is, my advice, and the textbook too, use calculator for this. All right, but don't be surprised if they ask you for the formula here. All right, guys, I'm going to sign off. Thank you.